Manjunath, we can start the session. Thank you.
Yeah, hi guys. Good evening, everyone. Good evening, guys. So I'm happy to welcome all of you people, and I take this pleasure to welcome you people for the day 5. That's the last day of our masterclass. So, firstly, I want to mention something that since 4 days, you people are being patient, being patient, and I'm very much grateful for your efforts, everything. So you are listening something very constantly. So it means a lot for everyone. So yeah, uh, let us quickly recap whatever we have seen in the last class. Then in today's session, we'll be dealing with something called our batteries. What is the use of the batteries? How the batteries are working? What happens in the batteries and all? Let us see. Then we'll be having we'll be dealing with the simulation part. So I'll show how the simulation works in the MATLAB. What is the use of this simulation in the MATLAB? Uh, that's what I'm planning for today's session properly. So before going into further or before starting regarding the batteries, let me know what are the different types of motors we are having in this electric vehicle. What are the motors we are using for this electric vehicle? Please. Only DC hub motor. I'm expecting answers from all the participants. What are the different motors we'll be having in case of this DC in this type of vehicles? What are the electric vehicle motors we'll be having? Just BLDC motors, permanent magnet synchronous motor, AC induction motor, and switch reluctance motors. Very good. So from this, from the yesterday's session, what are the motors that used in the two-wheelers? Yeah, very good. BLDC motors, which will be working as the hub motors. Okay. So they are used in the two-wheeler vehicles. Yeah. So where the what we say, where the permanent magnets are connected in case of the BLDC motor? Yeah, to the rotor. So I'm expecting answers from all the people. I'm not getting responses from all the people. Once, can you please quickly say is how many people are actively listening for this class? Because this is the day 5 where we will be having the ending for the session. So we have to discuss so many things. We'll be having so many things to do. Okay. So the one thing what I have said on the day 1 is we need to have the proper communication, proper response. Okay. So I'm looking for most of the people. Can I quickly get 174 SS from 174 people? Yeah, very good, Andy. Now, as you said that for the rotor we will be having the permanent magnets. I'm very happy to hear that. Yeah, whenever we are coming to the BLDC motor, in case of the BLDC motor, we'll be having something called brushless DC motor. Okay, in case of the brushless DC motor, where I'll not use any brushes and commutator rings. Yeah. Now, why should not uh, why should not I use direct DC motors which is having brush and commutator ring? What is the disadvantage with the brushed motors? Yeah, you will be having the sparks issues and you'll be having the loss in the efficiency. Okay, very good. I'm happy for that answer. Yeah. So whenever you are having these brushes and maintenance issues, you will be having something called that they are very much difficult to maintain. Okay. So maintenance issue will be very high. So if the maintenance issue is very, very high, then automatically they are not at all applicable for the electric vehicles. They are not known as the electric vehicle motors anymore. Okay. So we should not use those type of motors. Yeah, coming to the next type of motors, we'll be having something called our BLDC motor. In case of the BLDC motor, where we will be having the hub technology. Okay, they can be work as the hub motors also. So in case of the BLDC motor, I'll be having something called my permanent magnets, and also I'll be having something called my uh, electromagnets. Okay. How can I create the electromagnet? Yeah, I'm not presenting any screen. No need to worry. See, point is that whenever I'm trying to recap anything, I'll not present any screen. Okay. Yeah. So that is regarding the BLDC motor. So whenever we are dealing with the BLDC motor, we need to remember that uh, they are the motors which will be working on something called the electronic sensor. What are the sensors we are using in the BLDC motors? Hall, speed check. What are the sensors, Sandy? Yeah. In case of the BLDC motors, we are using the Hall effect sensors, where I can say that Hall effect sensors are something, the electronic sensors which are working based on, yeah, in generally, which they are working based on the rotor position. Okay. So here the Hall effect sensors are placed to identify the rotor position and to energize the respective stator winding. So this is the main cause of the Hall effect sensor in case of the BLDC motor. Okay. So if we are using this BLDC motor, whenever we are coming for BLDC motor, here I can use my BLDC motor in case like my internal rotor and external stator. And one more thing I can use is my internal stator and external rotor. The internal rotor motor is why more common, where the every motor will be working on the same condition, where my internally rotor is presented whenever the current is passing and all, my rotor will be rotating. Okay, so for that I need to have something called my shaft for the rotation and all. But whenever I am coming for the external rotor type, okay, here, these type of motors are known as my hub motors. So in this type of motors, I'll be having one good thing or one advantage is that my external part is rotating. So whenever the external part is rotating, yeah, whenever the external part is rotating, here what happens, Andy? Automatically, due to the rotation of the external part, if I connect properly a wheel to that external rotating part, automatically that wheel starts rotating. So it will be working as something called my hub motor, where I can easily use it in my two-wheelers. Okay, I can easily use it in my two-wheelers. Okay, then I'll be having something called the next type of motors is known as my AC type of motors. Okay, in the AC motors, the one AC motor I'll be having is my uh, induction motor. Okay. Do induction motors are synchronous or asynchronous?
Recording in progress.
Yeah, very good, Andy. Your internal motors are asynchronous type of motors. Okay. Yeah. Why? Because whenever we are dealing with the induction motor, in case of the induction motor, whenever the power supply is given for the stator will be producing the rotating magnetic field. So this rotating magnetic field is in generally measured as your synchronous speed or your ns. Okay, and whenever this rotating magnetic is produced due to this rotating magnetic field or due to this rmf, emf will be induced, and this induced emf will induce the current inside the rotor bars. And what happens whenever it induces the current inside rotor bars, your rotor starts rotating. Okay, here your rotor starts rotating. So whenever your rotor starts rotating, automatically the flux will be generated. Okay, the flux will cut the loop, and from there the current will be produced. But here what happens, initially your nr, if the nr is always equal to ns, then there is no cutting of the loop. Okay, here your flux will not cut the loop. Okay, then automatically what happens, there is no emf produced or there is no current will be produced. To overcome this situation, your nr should be always less than ns. So this is the case where they are known as the asynchronous motors. And in this case, as we discussed, that NR is proportional to the frequency. So if we can adjust the frequency, or if we can reduce the frequency, then automatically what I can say is easily uh, we can easily control the speed of the motor. Okay. Uh, then, ma'am, can you please allow me to share my screen? Yeah. So that is what happens in case of your what we say, to be precisely, that is what happens in case of your AC induction motor. Okay, that is what happens in case of your AC induction motor. Then will be just a minute, and I'll share my screen. Okay, so this is what happens in case of your AC induction motor. See, here you need to observe the beauty of electrical engineering is that whenever a normal DC supply is passing, you'll be having only one EMF or one magnetic field. But whenever a three-phase supply comes into the picture, then automatically we'll be having the multiple ways to create something. And here in that multiple ways, we'll be having a proper rotating magnetic field also created, because from the days of the electrical engineer or from the childhood of where we have habituated to listen something called our in case of the electrical engineer, we'll be having something that AC power and DC power, AC power and DC power, where whenever you are coming for the DC, you'll be having the discrete, and whenever you are coming for the AC, you'll be having the alternating power. So here the alternating power is saying that you will be having the three-phase supply. The three-phase supply is damn big, and which is creating the rotating magnetic field, and which helps to induce the EMF. So that's why it is known as the it is known, or in generally we can say that these type of motors working based on the electromagnetic induction. Okay. Electromagnetic induction principle. And next we have seen something called a permanent magnet synchronous motor, where I'll be having permanent magnets induced into the motor. So here what happens, you will be having the two fields. One is the rotating magnetic field for the stator and permanent magnetic field for the rotor. But in case of the permanent magnet synchronous motor, we will be having the proper synchronization between rotating magnetic field and permanent magnetic field. So there it will be running at the speed of the synchronous speed. So that's why they comes under the family of the synchronous motors. Then we'll be having something called switcher reluctance motor. Due to their noise issues and all, we are not using that type of motors as of now. So everyone clear regarding the motors? So everyone clear regarding all the motors? Everyone, yes, very good. And now, already we have discussed regarding the converters, which we will be having the inverter, we will be having the bidirectional inverter and all. Then we have seen what is the application of controller also. Now, for this controller or converter, or to be precise, for the motor, the power is coming from where the power is coming. It is coming from something called the energy sources. Okay, now let us start today's session with the energy sources. In generally, we'll be thinking that there is only one thing that which is delivering the power, that is our battery. Okay, so here one thing what I want to say is we don't even have only battery as the energy source. We'll be having few other energy sources like our batteries are one source of energy. Ultra capacitors are one more source of energy. Ultra flywheels are one more source of energy, and fuel cells are one more source of energy. So these are the four different sources of energy where my electric vehicle can be relay. Okay, because the point is that whenever we are coming for the electric vehicle, my motor need to have power. Okay, my motor need to have power. Okay, in general, if I take the motors at our home, we'll be having the continuous supply with the help of some wire and all. We'll be having the continuous supply. I'll be using that supply, and I can easily rotate my motor or something I can do. But whenever I am coming for the vehicles, okay, I can't carry a 1 kilometer wire, and for every 1 kilometer I can't switch my cable, or I can't switch my terminal for every 1 kilometer for traveling. Okay, but so what I need to do here, I need to have something called the storage device, which will be storing the electrical energy or storing some energy and converting it into electrical energy. So here, these storage devices are known as our energy sources. For the electric vehicles, in generally, we will be having the four different sources of energy. So those sources of energy are your batteries, ultra capacitors, ultra flywheels, and fuel cells. So fuel cells is something that which will be working based on the hydrogen principle, where we'll be having the proper hydrogen principle included here. Then whenever we are coming for the ultra flywheels, these are something that which will be working in the rotor. So here, once the rotor, first we need to give some power supply for the rotor. So whenever the rotor is rotating at that instant, that kinetic energy is converted into mechanical energy, and from there vehicle can absorb that sort of mechanical energy can be converted into electrical energy, and that electrical energy further need to be converted into mechanical energy. Due to the larger conversions, these ultra flywheels are not appropriate method. And next thing we can say is our ultra capacitor. So whenever we are dealing with the capacitors, we are habituated to listen, or we are listening in our labs and all that, we will be having something called our capacitors. So coming for the working of the capacitors, they are very small amount of energy storage devices where they'll be storing the energies in microfarads or millifarads of the energies we'll be storing. But whenever we are coming for one advanced concept in the capacitors, that is the ultra capacitors. In case of the ultra capacitors, in generally we can store thousands of farads of energy, which ultra capacitor can be charged in 7 minutes. Okay, if we take one ultra capacitor and one battery, if both are having same 300 voltage level, then the ultra capacitor can be charged in 3 to 4 minutes. If the same equivalent battery will be taking 3 to 4 hours. But one disadvantage with the ultra capacitor is whenever they are connecting in series, one disadvantage is that the voltage withstanding level of ultra capacitors will be very, very low. They can only withstand the voltage levels up to 1.7 to 2.3 volts per individual cell. So we need to connect a lots of cells in series to make the equivalent voltage level. So that is one of the major disadvantage with the ultra capacitor. And then coming for another disadvantage, they will be having low internal resistance. So whenever we are having low internal resistance, the charging time will be very, very less. And meanwhile, the discharging time also very, very, very less. So if we properly compare the charging and discharging time, so if a capacitor is charging in 3 minutes, it is discharging in 30 minutes. So automatically what happens, it is not that much suggestible method for electric vehicle as of now. So if we can if we can increase the internal resistance at discharging in, then we can consider this as something the good method or good source. Now coming for the Bahubalis of the electric vehicle, which I can call them as the batteries. Now let us understand the phenomenon inside the batteries. Before going into the phenomenon inside the batteries, this is what happened in case of your hydrogen fuel cells. So the thing I can say in case of your hydrogen fuel cells are, a fuel cell is a device that uses hydrogen or hydrogen rich fuel and oxygen to create the electricity. Okay, the fuel cells are more energy efficient than combustion engine, and the hydrogen used to power them can come from the variety of the sources. So if the pure hydrogen is used as a fuel, the fuel cells may emit only heat energy and water, and eliminating the consequences of the pollution. Okay, this is also one of the technology where now people are also looking, because along with the EV and PV, we can also focus on the fuel cell. Okay, then now comes the important thing of our electric vehicle, that is our battery. So mainly whenever we are coming for the battery technologies, what are the batteries we are using in electric vehicle are, we are using majorly 3 different types of batteries. There are lead acid batteries, then we will be having something called nickel metal hydride batteries, then we'll be having something called nickel cadmium batteries, and then we'll be having something called our lithium ion batteries. Okay, so if we properly observe these type of batteries, so can anyone explain what is the working principle inside the battery? What is the working principle of battery, Andy? Hi guys, are you there? Or only I am the one who is there in the session, which stores the energy and which separates electron, chemical to electrical, chemical to electrical. That is a conversion principle. If I am not wrong, what is the working principle? Yeah, let me explain. So before going into the working principle, what is a battery? A battery is a self-contained chemical power bank, which can produce a limited amount of energy. And coming for the batteries, the main components of are your electrode, separator, and electrolyte. So why they are important means they are something like storage devices which can store the energy. And coming for the working principle of the batteries will be working on the principle of oxidation and reduction. of the electrolyte with the metals. Okay, if I'm not wrong, this is what we have studied in the basic 8th class chemistry, where we have seen the oxidation of electrons and reduction of electrons. So this is the principle of the battery, where we'll be using the batteries are majorly working on the principle of oxidation and reduction. Okay, and what are the two operating modes we are having in the battery? Means the two operating modes we are having in the battery are charging and discharging. Okay, one more thing is the ideal state. We will not consider the ideal state as the loaded operation condition or connected operation condition. Coming for the proper operating conditions, we'll be having the charging and discharging. See here, you need to observe. This is one thing where which is very much important. During the charging, the electrons will be moving from positive electrode to negative electrode. Okay, during the charging of the battery, the electrons will be moving from positive electrode to negative electrode. This process is called oxidation. Okay, this process is called oxidation because here we'll be gaining the electrons. Okay, so if we properly observe, the positive electrode will be losing the electron, and the negative electrode will be gaining the electron. Okay, so this is what happens during the charging. And coming for the during the discharging, the electrons will be flowing from negative terminal to positive terminal, and this process is known as the reduction. Reduction means losing of electron. Okay, if we properly observe here, the whenever the electrons are moving from negative to positive, the negative will be losing the electron and positive will be gaining the electron. So if we consider the proper battery chemistry, in case of the charging, the batteries will be gaining the electron. In case of the discharging, the batteries will be losing the electron. Okay, so this is what happens in case of the charging and discharging of the battery. During the charging, we'll be having the oxidation, and during the discharging, we'll be having something called the reduction principle. Now, if this is the direction of electrons, then the direction of current will be always opposite to the direction of electrons. So during the charging, the current will be passing from negative terminal to positive, and during the discharging, the current will be passing from positive to negative. Okay, so this is what happens in case of all the batteries. So whatever the batteries you take, if you take the lead acid battery, you will be having something called the electrolyte as your H2SO4, and positive electrode will be your PbO and negative electrode will be your Pb, if I'm not wrong. Then whenever the charging is happened, then the H2SO4 will be divided into H plus and SO4 minus. Then SO4 will be reacting with PbO and giving PbSO4 minus. Then at that instant, the electron will be lost, and that lost electron will be moving towards the negative electrode. So this is what happened in case of your any battery. Okay, so the chemistry of battery is something different, where we'll be already learn, or where we can focus in the point of the chemistry of battery. But whenever we are coming for the working of the battery, this is what happens inside the battery. So the point means, the point whenever you are charging your battery, at that instant the electrons always tries to move from positive to negative. The point you discharge your battery, at that instant the electrons always tries to move from negative to positive. Imagine you are using a phone in the charging condition, then automatically the heat of the phone will be increased, or the heat dissipated by the phone will be increased, because one thing you will be doing the charging operation, one more thing you will be doing the discharging operation, where you will be having the collision of electrons. Whenever the electrons are getting collided, there will be the heat dissipation, and that heat dissipation you will be felt whenever you are touching the phone and all. Okay, uh, okay, so this is what happens in case of your battery. Okay, now I think everyone got the clarity regarding the battery operation, if I am not wrong. So this is what yeah, this is what the working of the battery will be having. So everyone is clear with the battery working? Yes. Done. Chalo, this is the working of your battery. So if we properly check the components inside the battery, we'll be having something called the electrodes, which may be your negative electrode and positive electrode. Then we'll be having something called our electrolyte. Electrolyte is something that which is the medium where the electrons can move, and then we'll be having something called the separator, which will separate the positive terminal and negative terminal, and it will protect the battery from the short circuits and all. Then we'll be having something called the current collector, which will be taking the current or giving the current. That is the work of the current collectors. Okay, yeah. Then before going into the making of a battery pack, let us see what are the let us see what are the uh, terminologies, or to be precise, what are the categories or what are the criterias we need to consider while selecting the battery. This we need to be more specific. Okay, so in from that, the first thing we'll be having is specific energy. The specific energy of battery should be very high, because if the specific energy and energy densities are very high, then the storage capacity of battery can be increased. So while we are selecting the batteries, we need to check what is the we need to be more precise that what is the proper specific power or specific energy of the battery, so that we can observe or we can understand the energy withstanding capacity in case of the batteries. Then coming for the specific power, in case of the specific power, which is representing the range of the battery, what is the range we'll be having in case of the battery, what is the maximum range we can attain, and what is the maximum range, or what how much range we can travel with respect to that specific energy we need to calculate. Then we will be having something called the typical voltages. We need to check the voltage ratings of the battery, and this should meet, or this should satisfy all the electrical equipments in the vehicle. Then we'll need to check something called our ampere ratio. Okay, where we need to check the proper current values and proper current ratios of the batteries. Then we need to check the energy efficiency. Is our batteries energy efficiency or not? That we need to consider. Then we'll be having something called the commercial availability. So we need to be clear that our batteries are commercially available or not. Then that is what the main thing we need to check. We need to be clear with the operating temperatures, as we discussed that they need to the operating temperatures need to from -40 to 60. That we need to be clear. Then we need to check is there any self discharging rate, because if there is a self discharging rate, without using the battery power, the battery will get drained out. So that's what we need to check. Then we need to be clear with the number of life cycles. So we need to check the proper life cycles of the battery, how many chargings and how many dischargings we'll be having in case of the battery. That is what the main thing. And coming for one more main thing is our battery cost. Okay, we need to be more precise regarding the battery cost, because the battery cost something the battery cost is something that the overall cost of the vehicle. So if we can reduce the battery cost, then we can reduce what I can say, then we can reduce the overall vehicle cost. So this is what we need to check properly. Okay, and coming for the battery cycles, battery life cycles, here a life cycle is one full charge and discharge. Okay, this is what the most of the people will be getting confused. And here I need to give one clarity that whenever you are coming for the battery cycle, a life cycle as battery, a life cycle of batteries depends upon one full charge and one discharge. Okay, coming for the charging, we'll be having the charging from 0 to 100 or 0 to 90 or 0 to 96 to be precise, we need to do. Then we'll be having something called our discharging, that is the depth of discharge. The combination of state of charge and depth of discharge once is known as the life cycle. Okay, now whenever we are coming for the life cycle of different batteries, okay, your lithium ion batteries will be giving nearly 300 to 3000. Then for case of the lead acid batteries, you will be having nearly up to 2500. Then in case of the nickel metal hydride battery, you will be having up to 1500 and all. Okay, now this is about the major battery life cycles where we need to be more concentrate. Okay, so if we charge our battery from 0 to 100 and then we discharge it back to 0, then it is known as one battery life cycle. But we should not there should not be any completely discharging and completely charging in case of the batteries, because they are made up of the lithium ion, which can't obey the fully discharging and fully charging. But if we charge our battery from 0 to 50 and then from 50 to 100 in the next day, okay, then this is also known as one full cycle, where one full cycle means you need to charge from 0 to 100 and you need to discharge up to 0. Okay, this is known as one complete life cycle in case of the battery. We need to be more precise regarding these life cycles. Okay, clear for everyone? Am I clear for everyone regarding these batteries and selection of batteries? Yes. Okay. Yeah. Then the next thing we will be having is how we'll be building the battery pack. Okay. So for building the battery pack, the main things we need to focus is we need to calculate the specifications. Then we need to check the supplies what we'll be having. Then we need to check the sorting and assembling technique. Okay, then we need to focus something called the motor ratings range what we needed, and finally we need to check the dimensions, because the dimensions plays the key role in placing while placing the batteries into the vehicle. Okay, yeah. Now whenever you are coming for the batteries, so before going into the batteries, one thing I need to say is battery is something which contains of cells, and whenever you are combining the the combination of cells will result in the modules. So whenever you are dealing with the cells, okay, here in case of the cells can be connected in series, or in case of other, those cells can also be connected in parallel. Okay, so whenever you are connecting the cells in series and whenever you are connecting the cells in parallel, the difference making is the sum of voltages and the sum of currents. In case of the series connection, the current will be common, and in case of the parallel connection, the voltage will be common. So this is how your series cells need to be connected, where the positive to negative, negative to positive, positive to negative, negative to positive. And whenever you are coming for the parallel connection, all the positives need to be shorted and all the negatives need to be shorted. From there, we will be extracting the positive and negative terminal. So this is what happens in case of the battery building. Okay, so the major this is how your battery pack will looks like. Okay, so the major components you will be having are here. In generally the cells you will be having. Next you will be having the nickel strips you will be having for the terminals, for creating the terminals. Then we will be having something called the battery holder to hold the cells. Then we'll be having something called the battery management system. Very soon we'll learn regarding this. Then we'll be having something called the insulators. Okay, and we'll be having something called the heat shrink sleeves. Okay, which will protect the battery from any heat conditions and all, or which will protect the wires in generally. Then we'll be having something called the connecting wires, which will connect the terminals. Then finally, we'll be having this into the metal casing. The cells you can see is the lithium ion cells. This is how your lithium ion cells will looks like. Then whenever you are coming for the manufacturing of the batteries, people simply saying that batteries are blasting, batteries are blasting, batteries are blasting. Before the batteries coming into the picture, or before the batteries coming into the market, these are the steps involved in making the batteries, where we will be having the cell preparation, terminal cutting, module assembly, module testing. Here the first testing will be happen, then you'll be having the modules will be assembled into the pack, then the packs will be electrically assembled, then you will be having the pack testing, then you will be having the final assembly. Again, we will be charging the batteries, again we will be testing. Okay, then the QC or QA pass sticker will be placed on that battery, then it comes into the market. So before coming into the market, the batteries itself have three stages of what we say, a proper three-stage of testing. So we can't simply say that these batteries are failing because of the manufacturers and all. Even though if we take the lithium ion battery, if once the lithium ion battery falls down, then we can't use that lithium ion battery for further applications. The live example, what I have seen in my career or in my life, is that whenever I worked on the drones, in the drones we used to have the 22,000 mAh lithium ion batteries. Okay, so one case what happened with our team is that we bought a new lithium ion battery. That lithium ion battery fell down from 3 feet of height. Okay, immediately after 4 hours or 5 hours, we seen that there is some bulge in that some what we say bulge of the shape in that battery. Even though we thought that we can use that battery, then immediately we connected the battery for the drone. We flew the drone. Within 1 or 2 minutes, the drone flew up to 1 kilometer of height. Then automatically it blasted in air itself. Then further R&D to gave us the hint or gave us the report that saying that this is happened because of the abuse to the lithium ion battery. Okay, so these sensitive the batteries are. So that is the reason where we need to use the batteries very carefully, even though we'll be having the protectors outside, but we need to have the batteries very properly, and we need to use the batteries very safely. Okay, then this is how the batteries are made up of. Okay, then something called our battery management system. Now, in the battery management system, before going into the battery management system, these are the reactions we will be getting whenever we are dealing with the batteries. Okay, you'll be getting sometimes sparks, you'll be getting sometimes flames and all. Okay, now what is the reason? Okay, in general, if you consider your batteries can operate safely, or to be precise, a cell can be safely operated in between 1.8 volts to 4.5 volts. Okay, the voltage level you need to give for your cell is 1.8 volt to 4.5. Okay, so this is the voltage level your cell need to have. Okay, then whenever you are coming for the temperature, okay, a battery can withstand the temperature from minus 40 degrees to 80 degrees. Okay, this is the safe operating area. Okay, if we are overcharging, then what happens? The cathode structure is stabilized and the electrolytes react sharply with the cathode and the anode. Then the lithium, what happens? Then it starts to violate quickly, and it starts to what we say explore quickly. Okay, this is what happened if we are overcharging. And in case of the high temperatures also, inside the batteries you will be having the electrons, they will be having their own respective orbitals. If the heat is continuously given for those orbital electrons, that electrons will get excited. If the electrons are continuously exciting, then automatically there will be the collision of electrons, and that battery will blast for sure. Okay, now how to protect that battery? Okay, how to protect that battery? So for the protection of those batteries, we'll be having something called our battery management system. A battery management system is generally an electronic system that protect the battery from operating outside the safe operating area, and monitoring the state, calculating the secondary data, reporting the data, and controlling the environment regarding this battery. Okay, see, battery management system is something that the electronic chip which you will be seeing. So what is this working? What is the working of this battery management system means? It helps the battery to work in the safe operating area, and it also monitors and controls the rechargeable batteries. So this is something that which is the heart of the battery. Without the battery management system, a battery can't work properly, because most of the cases we are using the lithium ion batteries. Okay, most of the cases we are using the lithium ion batteries. So whenever we are coming for the lithium ion batteries, they are very, very high stable in nature, and they can't used as they can't used for undercharging and overcharging. Okay, so whenever they can't use for undercharging and overcharging, by default what I can say is that if your battery is undercharged, it will drain out. If your battery is overcharged, it will explode. Okay, so to protect from these conditions, we are having something called the battery management system. So coming for the objectives of the battery management system, they are designed to protect the application, they are designed to protect the battery life, they are designed to prolong the battery life, and also they are designed to maximize the power delivered by the battery. So these are the so these are the something what I can say that which are very, very, very important in case of your batteries. And without battery management system, we can't do any monitoring and detecting operations. And what are the functions of the battery management system? Coming to the functions of the battery management system, the functions we are having here are we will be having something called the voltage functions, which will be taking care of the maximum and minimum voltage. Then it is responsible for the temperature to maintain the optimal temperature. Then it is responsible for the state of charge and depth of discharge. Here I need to explain something called the state of charge. State of charge is something that the remaining capacity by total capacity will gives you the state of charge. If your remaining capacity is 60 and the total capacity is 100, then your state of charge is 60%. That is what we'll be seeing in the mobiles, and that's what we are seeing in the cars. Then we'll be having something called the depth of discharge. In case of the depth of discharge, if you are charging your battery for 96% and if you are discharging it for something called 16 or 20, that the discharged 80% is known as the depth of discharge. Okay, this is also monitored with the help of the battery management system. It is also operating it is also function to monitor the state of power. It is also function to monitor it is also function to monitor the state of safety, where you will be having something called the coolant flow. It will be checking the current and coming for the protections in case of your battery management system. It is designed to protect the overcurrent. It is designed to protect the over voltage. It is designed to protect the under voltage. It is also designed to protect the something called your under temperature, over temperature, and this is something which is very, very, very responsible for the ground faults and leakage current detection. Okay, so if you properly observe this slide, over current, over voltage, under voltage, over temperature, under temperature, ground faults, leakage current, everything will be managed only with the help of the battery management system. Then whenever we are coming for one example of the battery. So this is what the battery which is used by Tesla Model 3 vehicle, where I'll be having the 75 kilowatt hour battery, in which I'll be having 4,416 cells, which are converted into 96 set of modules which are connected in series and 46 set of modules which are connected in parallel. So this is what we are building a battery pack in case of the Tesla Model 3 vehicle. Then whenever we are coming for the different types of the battery management system, we'll be having the centralized, distributed and modular battery management system. So in case of the distributed battery management system, every individual cell will be having the battery management system connected to it, and everything is connected to the master controller by default. Here, the master controller Here, the master controller will help something to monitor the individual cell. Then whenever you are coming for the modular battery management system, in case of the modular battery management system, set of cells are connected to one controller, set of cells are connected to one controller, and all the controllers are monitored by single master controller. Then whenever you are coming for the centralized battery management system, in case of the centralized battery management system, all the cells will be having only one controller, which is monitoring all the cells at a time. Then whenever you are coming for the battery management system, the input things will be giving are the current, voltage and temperature. And inside the control unit, you will be having the threshold values of current, voltage and temperature, which you will be having something called the lower limit and upper limit. Okay, which you will be having the lower limit and upper limit of individual thing. Then what happens? It will be monitoring the current, it will be monitoring the voltage, it will be monitoring the temperature, and based on the monitoring, it will be giving the output of state of charge, state of health, state of thermal management system, and then it will be doing the power optimization also, and everything is integrated towards the display. Okay, more precisely, this is what the block diagram where the battery management system is made up of. We will be having the battery monitoring here. Monitor data will be given for the battery state, where it will be giving the state of determination. Then the information is given towards the battery management with the help of the user interference. And then the electronic controller will be connected with the thermal management system. And the inputs it is taking is current, voltage and temperature. So based on this current, voltage and temperature, yeah. So if you are having any something called your current difference. Imagine that my optimal temperature should be less than 60 degrees, but I'm getting any 70 degrees. Then automatically here the thermal management system comes into picture, and it will be giving some sensors, it will be giving some communication towards the vehicle, or it will be operating the coolant mechanism that kept in the vehicle, or to be precise, it will be stopping the vehicle if the abnormalities are unavoidable. Okay, so most of the people are asking about the battery temperature control. This is what happens in case of the batteries. We will be having the proper thermal management system where it can easily help the battery to get out of it. Okay, and now coming for the main objectives of the battery management system, as we discussed, to maintain the state of health. Okay, then to maintain the proper cell balancing. Okay, all the cells need to be powered equally. That can be done with the help of the cell balancing. Then to wind it off for the battery management system, in the electrical vehicle, the battery management system working on monitoring, maintaining, protecting, isolating, compensating, and imbalancing the parameters, and providing information regarding state of charge, state of health, and providing the range possibilities. It is also responsible to provide the driver display alarms and all. It is also responsible to provide the charging for individual cells, and it is also responsible to respond and react for all the what we say, all the changes happens inside the batteries, and it is also responsible for the battery usage and abuse in case of frequency, magnitude, and duration. Okay, so this is known as the logbook function of your battery management system. Now everyone is clear with the battery management system. Yes, is it clear for everyone? Done. Okay, now let me explain what are the major precautions we need to take for the battery. Okay, to increase the battery life. One thing we need to do is we need to avoid the charging. Okay, we need to avoid fully charging and deep discharging as we discussed. Then we need to avoid the frequent fast charging. Next thing we need to store. Someone is asking that what happens the batteries will drain out or not, drain out or not. Batteries will drain out by default, but whenever you need to store the batteries, always try to store in the semi-charged state with the 50% of state of charge, and then always try to maintain the battery at the optimal temperature. So now don't ask me to keep the battery in the fridge or not. Okay, I'm not saying that at the cool temperature. I'm trying to say you people to maintain in the optimal temperature. Okay, chalo. So these are the major tips given by me to maintain or to increase your battery life. Okay, now whenever you are coming for the batteries, our batteries will be having something called the intelligent batteries, where intelligent battery consists of a memory chip which is programmed by a manufacturer with the information about the battery specifications. Here in the battery, we'll be giving the manufacturing data, cell chemistry, cell type, everything will be given. Now the intelligent batteries will be working in such a manner that it is displaying the battery level, it is displaying the battery life, it is displaying the auto discharging is on or off, then balancing of the cell, overcharging protection will be having, over temperature protection will be having, over current protection will be having. So everything will be displayed, everything will be shown by your battery management system. So whenever we are coming for the electric vehicles, in the electric vehicle, the battery management system and the design of battery management system itself takes a week or 10 days to learn. Okay, so here you will be getting a baseline clarity regarding the battery management system, but whenever you need to learn them properly, the battery management system itself takes a week or 10 days to learn, because it's one of the ocean where we'll be having a lots of things to deal. Okay. So to be precise, this is what the intelligent batteries, this is how your intelligent batteries will be working. Okay. Then we'll be having something called the intelligent chargers. Whenever we are having the intelligent batteries, then automatically we'll be having something called the intelligent battery chargers. The smart batteries plus smart chargers. The intelligent batteries also need the intelligent charger. The charger is programmed to respond the input from the battery to optimize the charging profile. Okay, here the battery will be giving the response or the signals toward the charger to optimize the battery profile. Charging at the maximum rate until the present temperature is reached. Okay, so here the charging is also happen based on the temperature, then slowing down or stopping the charge or switching on the cooling fans. Okay, so whenever we are trying to charge the batteries, if we are going for the fast charging methods, there automatically what happens, we'll be having the heat dissipation. To overcome the heat dissipation, we'll slow down the charge or we will on the cooling fans. We, in the sense, battery management system will do this. Okay, so if this is not happen, your battery will permanently damage. Okay, a smart battery charger can mainly a switch with the mode of the supply, which has ability to communicate the smart battery packs battery management system, where we'll be having the proper battery management system and where we'll be having the proper battery charging analysis. This is what happened, which will helps to protect the battery. If we overall see the hierarchy, what we have discussed so far, your battery is completely having the battery management system, thermal management system, intelligent chips, intelligent chargers. So if we consider all these things, is there any possibility for the battery damages? No, we will be having very low possibility or less possibility in case of the battery damages. Okay. Now, whenever we are coming, even though we will be thinking that there are some battery failures. Now let us see what are the reasons for the battery failures. Okay. So now whenever I am coming for the failure of the battery, one thing I can say that the batteries are failing because of the cell design faults it is having. Okay, so whenever you consider the battery, you will be having something called the designing faults. So this is one reason where the batteries may fail. The next thing we'll be having is the manufacturing process is out of control. If there is any proper quality check is not happen, because whenever whatever the environment of work we take, or whatever the working we take, there are some people or some quality analyst people or some employees who may not work efficiently, or who is not that concentrated regarding the work. Okay, so what they may do, whenever it comes to the quality check, they may not check it properly. If they may not check it properly, then automatically what happen, the overall output will get affected. That is what one thing happens in case of the battery failure. And one more thing is, by default we'll be having the aging. Okay, so whenever we are coming for the aging issues, once the batteries are getting aged, then automatically the batteries will get damaged. Then we'll be having something called the uncontrolled operation. Even though if we are having this all the systems, sometimes the batteries, sometimes not, none of the time batteries will be overcharged because of the cutting technologies we are having. But previously, whenever we don't have these technologies, because of the overcharging also, there are some cases where the batteries will get damaged, and some external factors like BMS can fail, the sensors can fail. There will be having some loss of coolant fluids also. So if these such things happens, then automatically the batteries will fail. Now, what to do in case of the battery failure? The only thing we can do in case of the battery failure, or the only thing we can do for protecting the batteries are using of the battery management system. If we can use the battery management system, they will prevent all these failures, and they, if the failures are unavoidable, then at least they'll try to minimize the effect, or at least they'll try to minimize the consequences. So the battery management system should, however, also to be designed properly and protected properly, where it will be protecting the battery as well as the user. Okay, so without battery management system, a vehicle can't work properly, or a vehicle will not give the 100% efficiency. Okay, so this is what regarding the battery management system and the batteries. So everyone is clear regarding this battery management system and batteries? Yeah. So this is what regarding the batteries and all. Uh, I think everyone is clear regarding the batteries. Now we have seen the selection criterias for the batteries, and now we have seen the selection criterias for motors. Now let me quickly show how to calculate the battery rating, or now and also let me quickly show how to calculate the motor ratings in case of the MATLAB. Then I'll show one simulated thing, what happened and how the simulated things will be there in case of the MATLAB. Uh, Let us first start with the one thing that is our coding part. So the point is that whenever we are dealing with this electric vehicle subject, I think 98% of the people are getting more excited, more enthusiastic regarding the things we are dealing in the last sessions. Okay. One thing I can say is that so now you people made one great thing that you have joined for this webinar, or this to be precise, the master class. I got even some are with your interest, some are with your faculty interest, or some for certificate, whatever the reasons may be there. But you people are joined for this. But one thing I can say is that if you continue to learn regarding this electric vehicle technology, then you will be having a great future. Okay. Uh, See, the point is that when we are dealing with these type of sessions and all, you will be having a, what we say, a great interest you will be getting. And one thing is that you people are going to work on emerging technologies, not like any others. Okay. See, whatever the emerging technologies we are having in this electrical domain are, we need to work on the renewable energy sources. For default, we need to work on them. Okay. So we got the opportunity to work on that. Let us utilize this opportunity, and let us look forward for using this opportunity. Chalo. Now let me present my screen quickly. Yeah, can you see my screen? People who are asking the notes certificate in the chat box, can you please stop those messages, because they may be create some disturbance for the running class. So at the time of whenever the time happens, the people will automatically share the feedback. You just concentrate on the things what happening in the class. Now, can you see my screen? Where I'll be having something called the Word document, in which I'll be having something called the motor or define vehicle parameters. So whenever I'm trying to calculate the motor, I have seen few different things for calculating the motors. Okay, whenever I'm coming for the calculation of the motor, in case of the calculation of the motor, I need to calculate my motor in such a way that we will be having some categories, or we'll be having some parameters we need to consider. First, we need to check the vehicle mass. Then we need to have the rolling resistance, where we'll be getting from the mechanical vehicle part. Then we need to have the aerodynamic drag. Rolling resistance is something that which will oppose the vehicle speed that we need to overcome. Then we need to have something called the aerodynamic drag, which will oppose the opposition air and penetrate into that air. Then we need to check the vehicle frontal area, vehicle density, vehicle acceleration, velocity. Every value need to be selected. Then what we need to calculate is we need to calculate the motor power torque. For the calculation of the power torque, we'll be having something called this code we'll be having. Let me have this code directly into the MATLAB. From there, I'll explain how the output will be getting in the MATLAB. And then see, these are the formulas we are using for calculation of the motor. As I said that every concept in the electric vehicle will takes at least 5 days to learn. Then only we'll be having the proper output. Then only we'll be getting the proper output. Okay. Then let us see regarding the motor speed torque. Okay. How the motor speed, how the motor torque need to be calculated with the help of the MATLAB. Just bear with me. I'll just copy the code, because if I keep on writing the code, then the entire time will go for writing this code itself. Now, can you people see my MATLAB screen? Yeah. Okay. Here, just in the MATLAB, if you see the MATLAB is something that where you will be having one window or one thing where you can write the code. Okay, where you can write the code properly and where you can execute the code. And one more thing we'll be having in case of the MATLAB is the simulation. Okay, so before going into the simulated picture, or before going into the simulated figure, or before going into the connection, to be precise, the one thing what I want to show here is the output where I'll be having from my vehicle things. Okay. So can you see my screen here? Yeah, in this screen, if you properly observe now, here we'll be having something called the mass of the vehicle is defined. Then we'll be having something called then we'll be having something called the gravity is defined. Then we'll be having something called the coefficient of radius is defined. Rolling resistance, that is. Then we'll be having the aerodynamic. We'll be defining these all the values where you'll be getting while designing the vehicle. Then we'll be having something called your area. Then we'll be having something called your rho, which is the which is the air density. Then velocity we need to define. Then we need to define the wheel radius. Then we need to define the theta, which is the gradient angle. Once everything is defined, what we are calculating here means the first thing we are calculating here is the rolling resistance. What is the rolling resistance we will be having? What is the aerodynamic drag we will be having? Then what is the then what is the gradient? What is the gradient frequency, or what is the gradient force we will be having? Then we need to check what is the acceleration. Okay. Now, if we can add all these things, we will be getting something called the traction. That force of traction, or that the traction force is known as some force which the vehicle need to have to overcome all the oppositions, and with the help of the traction force only your vehicle will be moving. With the help of the traction force only your vehicle will be moving. Okay, this traction force is supplied from the motor. Okay, so before selecting the motor, we need to select the traction force. Then we need to check the torque. We need to check the speed. Okay, then we need to calculate the power. Once the torque, speed and everything is calculated, here
the output you will be getting, can you see the highlighted one? This is what the thing we will be getting in case of the output. In the output, what we have got, the first thing we have got is the total tractive force, the force required to move this 300 kg vehicle with the gravity of 9.81, which is having the rolling resistance of 0.015 is 897.66 newtons. 897.66 newtons is the force required to move the vehicle. This force should be supplied from the motor. This force need to be supplied from the motor. Then the torque required for this vehicle is 269.30 Newton meters, and the power required for this vehicle to propel is 22.44 kilowatt, and the required motor speed here is 795.77 RPM. So whatever the motor we are selecting here, we need to select the motor in such a way that always choose the motor with the power greater than the motor's power obtained from the code. Okay, choose the motor with the power which is always greater than the motor obtained motor power. Then we need to check the motor torque. Okay, here the motor torque should be always greater than the torque of the wheel obtained, and then we need to check the proper RPM ranges. Then we need to check the proper RPM ranges. Okay, so if we properly calculate these things, the things we got is the total tractive force is 897.6966. So to be precise, I need to take my motor which is having the total tractive force of 900 newtons. Then I need to take my vehicle which then I need to select the motor which is giving the torque which is greater than 269, that to be precise 280 Newton meters. Then I need to have my motor which will be delivering the power of 23 or 24 kilowatt. Okay, then my motor speed should be 795.77. To be precise, I can go up to 798 or 799 RPM. So this is what the motor I need to select. Now I think everyone got the clarity how to calculate the motor terminologies and how to identify the selection of the motor. If anyone is already known this, they can directly practice. If anyone is new to this, you can easily identify what are the things happening here. Yeah, this is, if we take the example of the illustration, there you will be having the constant values only. And whenever you are coming, yeah, see, these the maximum values will be constant. The maximum power, see, the motor power means the maximum power supplied by the motor is 22.4 kilowatt. That will be changing based on the input power you required or input voltage you are giving. Okay, so the motor can withstand up to 22.44 kilowatt. Okay, that is what I can say that in the fully loaded condition. Okay, so this is regarding the motor calculations. Everyone clear with this? Do everyone present in the class? Can you quickly respond? Yeah, this is regarding the torque and power. Now let us see the same motor calculation with respect to what we say our motor, what we say with respect to our electrical values. Okay, so whenever we are coming for the electrical things of the motor, okay, here we need to be more precise that what is the back EMF we will be getting from the battery, what is the peak current my motor need to have, what is the inductive reactance, and what is the power factor motor need to supply. For that one example, I will be taking where the motor with the 5 kilowatt hour power. So this is what the example I will be taking with this example. Let me show how the values are working. Just a second. Yeah. Now let me continue code with this one. Yeah. Now, if you properly check here, okay, from here, I have used something called my, okay, this is what the required motor speed where we have seen. Okay, this is what the required motor speed where we have seen. Now we have calculated the things with respect to the speed and all. Now let us see the things with respect to the electrical components in the motor, electrical parameter calculations in motor. So we have taken one example in that we are trying to calculate the mechanical speed. So based on the mechanical speed, we'll be calculating something called the electrical speed. Then based on that, we'll be calculating the back EMF. So if we take this example, in case of this example, the back EMF we need to have is 0.0344 volts per radians per second. Then we need to have the peak phase current as 44.55 and RMS phase current as 31.50. And the stator resistance drop we will be having is 2.23 volts. And the power factor here we will be having is 0.30. And whenever here we are coming for the peak phase current and RMS phase current, there you will be having the difference in the values. Okay, so these are changing from motor to motor. The one thing I am saying is that how to execute the code in the MATLAB and how to select the code, because in real-time scenarios we will be having the different changes. We need to make those changes and we need to apply. Okay, see here the power factor is very low because the thing I have taken is very abrupt values. Okay, here I am taking for the 5 kilowatt. For the 5 kilowatt battery, I'm for 5 kilowatt motor, I'm just using the 72 volts of the battery. Okay, so automatically the power factor will be very low. The one thing I'm saying is this is not the real-time effect. Okay, this is not the real-time data. So this is the data where we'll be using for calculation. Okay, so whenever we are dealing with the real-time data, then we'll be checking properly. But the one thing you need to check here properly is whenever you are dealing with the 5 kilowatt of the motor, we can't use the battery of 72. Okay, we can't use the battery of 72 volts. Okay, so this is just an illustration where you need to understand how the things are working. Okay, so no one will give you the approximate exact values which are working in the real-time industry. Even though I am working on the real-time industry on the motor and battery calculations, but we never reveal the things happening inside the industries. Just the one thing what we can say is how the things are happening and all. That's what we can say. Then yeah, just a second. In code, what you can change in code, you can change the values, but there is no need of changing any code and all. You can change the values. It depends on the variant you want. So all of you clear with the electrical parameters of the vehicle? All of you clear with the electrical parameters and selection of motors? Everyone? Yeah. Okay. Now, let me quickly show the battery thing, and let me quickly show the simulation connection. Then we can wind it off because it's already being 8:30 and we need to have the doubt stationary also. Just bear with me for a few seconds or few minutes. Let me close the existing code. So this is what the command we'll be using for closing the existing code, where I'll be closing my existing code. Enter every code is okay. Yeah. So yeah. So whenever you are coming for the battery ratings and battery capacity, so here whenever you are coming for the battery capacity, If we take the ranges and all, okay, so with the help of the ranges and all, we'll be finding the voltage, we'll be finding the battery C rating, we'll be finding the battery AH, okay, we'll be finding the current of the battery. Then we'll be having something called the energy consumption per in case of the battery. Okay, we'll be having something called the energy consumption in case of the battery. Guys, just a minute. I'll have some water. Yeah, then this is what happened in case of your battery. Okay, this is what happens in case of your battery calculations. Okay, here you can clearly observe the energy consumption. Okay, here you can clearly observe the energy consumption. Uh, where whenever you are coming for the energy consumption, okay. So here we will be having the energy consumption for kilowatt hour per kilometer. Okay. Can you observe here? The energy consumed for the kilowatt hour per kilometer is just 0.20 kilowatt hour. Okay. Where in case I am using the 5 kilowatt motor, whenever I am using the 5 kilowatt motor, in that case, the energy consumed for this motor is this vehicle is just 0.2 kilowatt per kilometer. It's very, very less. And the total battery capacity required in this case is 20 kilowatt hour. And the battery ampere hour ratings we need to have here is 277.78. Okay. See here, what I have given, I have given something called here 72 is the voltage of the battery, and the ampere hour capacity we have calculated is 277.78. Okay, if you multiply with this 277.78 with the 72, the something you are getting is 20,000 watt hour, that is your 20 kilowatt hour. This is how we'll be calculating the capacity of the battery. So whenever you are dealing with the battery, you will be having something called the voltage rating, you will be having something called the ampere hour rating, and if you multiply the voltage and ampere hour rating, you will be getting something called your kilowatt hour rating. So all of you clear with this battery calculation? Everyone? Can you quickly respond in the chat box? I'm waiting for the raining responses in the chat box. Yes, 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 yes. Is this session is exciting, or is this session is more insightful for you people? Yes, amazing. Okay, thank you guys. Chalo. Now let us quickly. Yeah. Now let us quickly jump into one simulation. So whatever the calculations I have made based on this calculation, I have done one simulation thing which I'll be showing the connections, and where the running pictures already extracted here. Here you will be having the different graphs. Okay. Let me show all the graphs and all. Just give me 1 minute. Then I'll quickly switch into the simulation and I'll again start sharing my screen. Guys, if there are any doubts, you use the chat box. Don't use the chat box for asking something like the feedbacks and all. The feedback will be sent at the time, at the scheduled time. You will get the feedbacks. No need to worry regarding the feedback form. And once you get the feedback form, I will also inform. Okay, no need to worry. Yeah. Okay, guys. Now let me know before I start my simulation thing. How many of you people are interested for this electric vehicle internships and paid courses where you will be getting immense of knowledge which can help for your future? Who are interested, can you please quickly put S in the chat box? Yeah, guys, most of you people are asking what is the cost, what is the cost, what is the cost. So what I'll do is I'll give this complete package of electric vehicle technology for 1 month, okay, which is starting from Monday onwards for 5,000 rupees. Okay. So in this 5,000 rupees, you will be learning every in-depth of knowledge from the basic of electric vehicle technology, where you will be learning. See, the point is that in these 5 days only, you have covered a lot of things. In the further sessions, you will be having more in-depth of knowledge regarding this, and you will be having hands-on experience in case of the simulation. You will be having what I can say is you will be having yeah, let me show the simulation one and all, then you'll get the clarity. you will be properly designing a vehicle by the end of your 1 month internship. Okay. So this is what the advantage you will be having with respect to this what 1 month internship. Okay. So yeah, this is what one thing I can show. Here I'll be having one simulation. This is a basic, very basic level of the simulation of the vehicle we'll be having. So such vehicles you will be designing, and you will be writing. You will also be have the proper hands-on writing of the code also. Okay. So now you are interested for this course for 5,000 rupees of the fees. If yes, can you quickly say yes in the chat box? Guys, I am waiting for your response. Yes. So are you interested for this session? Yes, yes, yes. Price is high, price is high, price is high. Fees is problem, fees is problem. Guys, one thing I want to say you people that the same simulation thing, the same coding process, and the same certification course for 1 month, nearly the people are charging 20,000 bucks and all. Okay. But most of you people are listening our classes from 5 days. So one thing what I can do for you people is in coming 1 week or in coming 1 week, we will be issuing the certificates. Whoever approach our team with the help of the certificate, okay, we are giving the certificate for you people. If you show that certificate, then immediately we'll be giving the same course for 3,500 rupees. Okay, so this is what the discount you will be getting, and the batch will be starting from Monday onwards. Okay, so now are you okay with that fees? Are you interested to join? This is very much helpful for the second year, third years, and final year people. Okay, so even though if you are going for outside any sessions and all, you'll not get something just a normal certificate course for 3,500. Here you are getting the proper course in online itself. Okay, see, here you will be having the two things, online and offline will be running parallelly. Whoever want to connect, they can connect in online, and if you want to come for the offline also, we will provide the offline sessions for you people at Hyderabad. At Amirpet we can provide the offline classes, and daily you'll be having 1.5 hour of class for 1 month, which is starting from May 5th onwards. So whoever interested in these classes, yeah, if you registered for the 3,500 course, in that you will be having the proper training, one-on-one training you will be having. There you will be having the training, and every individual will be practicing on MATLAB. Every individual will be designing the vehicle, and along with that you will also getting the lifetime recording access also. Okay, you will also getting the lifetime recording access. Okay, now one final time I'm asking how many people are interested in this? Can you quickly post S in the chat box so that I can go for the further session and I can wind it off? Yes, yes. Yeah, for brochure and all, you can contact the team. The team will post the details in the chat box. Okay, feel free to contact. You'll be having the numbers. So if you can contact to that number, then automatically you'll be getting the things. Okay, so from May 5th onwards, you will be having the classes. So whoever interested for this class, if you show this certificate of the 5 days masterclass, then you will be getting the course for 3,500. Where whoever are interested to come for offline, you can come to Amirpet, or else you can directly connect in the Zoom. Okay, daily you will be having the class of 1.5 hour, and only the discount is applicable for the students who are having certificates. Okay, chalo. Yeah, let us keep this aside and let us come back to the last part of our 5 days masterclass, which is the simulation part. So if you check it properly, this is the vehicle. Okay, this is what the electric vehicle, this is how the electric vehicle will be simulated. So initially for simulating the electric vehicle, you need to have something called the vehicle body. Okay. initially you'll be having something called the vehicle body. So for the vehicle body, we need to connect the tires and all. Okay, so this is how the tires are connected, and in the vehicle body we will be having the rotor speed and which will be having the rear axis speed and front axis speed. They need to connect it for the respective wheels. Okay, then from here, as we discussed, the motor is yeah, the motor is connected connected to the gear. Okay, the motor is connected to the gearbox. Okay, here we can use the gear or we can exclude the gear. There is no need of the gearbox here. It depends on the variant we are selected. The selected variant we are using the gearboxes because this is for the two-wheeler vehicle we have designed. Then we'll be having something called our BLDC motor or some different motors. From here, the motors are connected to the H-bridge controllers. Okay, from here, we'll be having something called our H-bridge controller. So whenever we are having the H-bridge controller, this H-bridge controller is helpful for the smooth operation of the motor. Then we'll be having something called our what we say PWM converter, which we already discussed, which is your PWM controlled voltage. Then this PWM controlled voltage is integrated with the H-bridge converter. Then we'll be having something called our driver longitudinal. Okay, longitudinal driver we will be having. For the longitudinal driver, something we'll be having here is the reference voltage or the difference velocity, which is given from the vehicle body. The vehicle body's velocity is given as the reference for the driver. Sorry, feedback for the driver. Then the reference will be given for the source. So if we properly observe this one here, here you can observe. We can even plot our own drive cycle. Okay, so here this is also explained in detail when in those internships and all, where you will be having the proper in detail drive cycle configurations and all. Then here the two inputs we will be having from the vehicle are acceleration and deceleration. For the acceleration and deceleration, here we will be having something called our voltage controllers or yeah, just a second. Yeah, here we'll be having something called our controlled voltage sources. One controlled voltage source is given with the acceleration and one controlled voltage source is given with the deceleration. Now these acceleration and deceleration inputs are given back to the H-bridge controller as we discussed, and that controller will be giving information towards the battery I'm having here. Then the battery's power will be delivered towards the motor as we discussed. From the motor, the rest of the vehicle will be operating. From the motor, the rest of the vehicle will be operating. Now, if we connect this, if we select this battery's voltage can be, this battery's current and voltage, everything will be observed in detail in this state of what we say state of charge. In the state of charge, again, we'll be using something called the gain and integrators. Okay, so with the help of the gain and integrators, they are connected towards the display. So if you properly observe, as we discussed in case of the vehicle, so whenever the input is given by the driver, whenever the driver inputs are given, okay, whenever the driver inputs are given, those inputs are carried towards the battery, and the battery will be delivering the power towards the motor. From there, the vehicle will be getting powered. But whenever we are coming for this exact simulation method, okay, here without battery also we can run the vehicle, because the H-bridge converter itself acts as a battery whenever we are going for very small model vehicles. This is one of the very small model vehicle where we have designed. And if we check the proper output curves, this is how the running curve of the battery we will be getting whilst when we get simulated. So at the initial moment, we'll be having very zero speed. Okay, at the zero speed, the torque will be very high. As the speed increases, the torque will be reduced. This is what the torque speed characteristics of the vehicle will be having. This is what the torque speed characteristics of the vehicle will be having. And then finally, what I can say is for this battery, we can also observe the state of charge and the time ratio, which I can call it as a driving cycle. So this is what the driving cycle we have extracted for this vehicle, where the driving cycle is in such a manner that once the time is increasing, once the load is increasing, the capacity of the battery or the state of charge is getting decreased continuously. Okay, so this is what the simulation we can do. Okay, so in the simulation, these are the things we will be calculating, where we are calculating the things starting from the vehicle body towards the drive cycles. In between, we'll be having the longitudinal drivers, where we'll be having the hedge bridge controllers, where we'll be having the controlled voltage levels, and we'll be having something called the signal converters or the solver converters. Then we'll be having the proper controlled current sources. Then we'll be having the current sensors. So everything will be sensed. So if you properly dissect a very, very basic vehicle of electric vehicle, this is how the things you will be having inside the electric vehicle. Am I clear for everyone now? Is that clear for everyone? Yes, I won't respond for everyone. Yeah. So for making this simulation and all, it will take nearly a lots of time. But for making this simulation and all, we will be having a lots of efforts need to be kept, where we need to include all the things and all. Okay. So this is what we can cover in this short time. So this is how the simulated vehicle will looks like. And this is how the vehicle internal connections we will be having. And further, this is converted into the blueprint. And from there, we'll be having the proper powertrain designing. So if I exclude these things and if I just conclude this set of things, okay, from the state of charge. Yeah, from the state of charge towards my what we say motor and all. So here what I'll be getting is something called my powertrain. This is what the powertrain designing will be having. Okay. Now, if everything is clear for everyone, we are done with the session. So I think everyone got one clarity regarding what the vehicle. On the day one, we have just started with the basic of the vehicle, where the wheels are rotating. But coming for the day 5, we have seen something called the simulated figure, where we have seen something called the simulated graphs, where in the graphs we'll be having the proper voltage, proper we'll be having something called of the stator, what we say state of charge and all. And then we will be having something called our motor torque speed characteristics. So I think everything is clear for everyone. So if everything is clear for everyone, I'll stop the session. Then the session will be open for the doubts. Yeah. So guys, yeah, just a minute.
Yeah, there is.
Yeah, just a minute, Shivani. Yeah. Yes, Shivani.
1 minute, Manjunath.
Yeah. Guys, just wait for few more minutes. You'll get the feedback link. The thing what we have discussed in the day one itself, try to understand the concept and all. Just a minute or 2 minutes, you can easily fill the feedback link. No need to worry regarding the feedback link. So even though if you want the same sessions from tomorrow onwards, you'll not get it. Yeah, sorry, Andy. We can't provide any PPTs here for these sessions. And the recordings you can find in the YouTube, where in the live column, you can find the recordings of the 5-day sessions. From there, you can access through the recordings. For the VLSI, we'll be having something different fees and all. For that, you can contact to our team. Our team will let you know regarding the VLSI course and all. So
Yeah,
now I have
Manjunath,
completed. Yes, Shivani.
there is one announcement.
Yes.
Yeah. Hi guys, there is one announcement. We are starting a new batch for electrical system design on May 22nd for final years and recently passed out students. Interested students can register through the link provided, or else you can contact our team. I'm giving the numbers in chat box. You can feel free to contact. And here we also providing a discount of 10%. Students who are showing this 5 days masterclass certificate to our team, they will provide 10% discount on the fees. Okay. Interested students kindly contact our team and show your certificate and get 10% discount on the fees. And we also launching one more batch for the second years and third year students, that is Tech and Niche program, which we focus on industry oriented knowledge. Interested students kindly contact our team. They will let you know about the all details regarding Tech and Niche program and as well as electrical system design. Okay. Yeah. Thank you, Manjunath.
Now I'll open the session for doubts. Guys, the session is open for doubts. If you are having any doubts, you can quickly ask the doubts. Yeah, the chat box is open for you. I'll be reading the chats. Yeah, regarding the certificate, within 7 working days, you will be receiving your certificates to your registered mail ID. We need to know how much days course will be. We have completed 5 days of masterclass. You are asking regarding the internship. Internship will be for 1 month. Whenever you are coming for the job oriented courses, in case of the electrical job oriented courses, we'll be having for 60 working days, where you people will be trained properly on electrical system designing, and there you will be having the 100% placement assistance. Then along with that, as our team informed, we'll be having one more batch, that is a Tech Enrich batch, which is helpful for the second years and third years. In this program, you will be engaged on different concepts in every semester, and you'll be having this every semester wise concept from second year onwards. In 2-2 you'll be trained on basics and AutoCAD. From like that, in every semester you will be having something, and then in the final years you will be trained on the complete system designing, and then also you'll be having the placement assistance. Okay. So I think you don't have any doubts. On EV also, if you registered for the full-time course for system designing job-oriented course, you will be having the placements. For internships, they are the certificate-based internships and knowledge-based internships you will be having. It depends upon your interest, in the both online and offline, the teaching will be same. So if you can come for offline, you just take the offline session, or else you just go for the online one. Yeah, we are planning for workshops on motors and all. You will get to know all the informations. Try to stay connected with the HAW regarding the with respect to the LinkedIn sessions and all. From there, you will be getting a lots of information. And one thing I can say that we are not like the some other institutes that where you will be having a improper training and improper placement assistance. If you check the proper record of the HAW, we are in this training and placement industry since 2010, where we have trained nearly 1 lakh plus students, and we have given thousands of jobs in the market. So as a HAW representative, one thing I can say proudly, that whatever the top MNC company you touch, from every company you will be having the HAW students. That is what the credibility we have created in the market. And one good thing we will be having is we have MOUs with nearly 400 plus companies, where they are very much trusted on us, because the main agenda behind the HAW is to create the employment for the electrical and electronic engineers. Because if you are directly going for the market, there is very less demand, because the people are just passed out with some knowledge. But whenever you are coming for the jobs, you need to have you need to have a proper industrial knowledge along with that what we say curriculum knowledge. Curriculum knowledge is not at all enough for getting the job. Okay, so one thing I can say, that all of you know what is the working of circuit breaker, but none of us know how the circuit breakers are designed, how to design the circuit breaker. All of us know what are the wires, and none of us know how to select the cables. Okay, so those every individual thing will be explained by the industrial experts in the HAW, so which will be very much helpful for you people. And one thing what I can say is that in this 5 days masterclass only, if you check yourself properly from the day 1 to day 5, yeah, one thing I want to ask for you people, did you learn anything from day 1 to day 5? Did you seen any good thing in this 5 days masterclass? Can you respond me in the chat box? Yes. Yeah, can anyone respond me? Can everyone respond me in the chat box? Yes, definitely. Yes, a lot. See, this is what the impact we created just in 5 days, just in 10 hours. Okay, so to be precise, in 8 hours of the sessions, we have created this much of impact. Imagine if we are connected for months, then you will be getting a lots of immense of knowledge from our side, along with the placement assistants. So no need to worry regarding that. So whoever having what I can say is, whoever having enthusiastic, or if you are planning to have a career in electrical engineering, just blindly walk into HIW. And one thing I can assure you people is, you can keep your happy face, and you can go out of HIW with the placement. See, the one thing I'm saying in this open media, open stream, means that's what the credibility we are having. Okay. Yeah, if anyone is having any doubts also, the session is open for doubts. Regarding the certificates, no need to worry. Within 7 working days, you will be getting the certificates. Tilak, I am not getting your doubt, because you are giving something else. Let me know clarity. Is there any companies for EV design in Hyderabad? Yeah, there are lots of companies who are working on EV. See, the point is that in the EV, you need to be ready to work not only in the designing, you need to be ready to work in all the segments where you need to increase the experience. Yeah, next. For any contacts and all, you can directly contact to the team HIW, where will be answerable for every questions and all. The recordings is kept in the YouTube. From the YouTube, you can get the recordings. And coming for the PPTs and all, in the masterclass, we can't share the PPTs, Sandy. Sorry. Yeah, that's what the internships we'll be having. So the point is that if you want to take the internship as an outside person without certificate, we'll be charging 5,000. But if you are using this masterclass certificate, then you'll be getting the same internship, which is starting from May 5th onwards, just for 3,500. One thing I can say guarantee that no one will give this much intense internship for 3,500, because see, we are not talking on the day one regarding this internship. We are talking regarding this internship on the day 5, okay, where you got a crystal clear clarity regarding the HIW trainers, how good the training is happening and all. Yes, you will be having a lots of jobs and all. Yeah, you'll be having the hands-on session. If for the offline students, you'll be having the hands-on session, and for the online, you'll be having the simulation part and all. Chalo, any other doubts, or shall we wind it off for today?
Yeah,
So I think
Manjunath, there is one
uh,
more announcement.
yes.
And we also starting our new batch of VLSI is on May 22nd. Interested students kindly contact our team. They will let you know about the fees details and course details, everything. And we are also launching our new batch of mechanical and civil. If any of your friends are there, kindly refer to them. And interested students kindly share our numbers to your friends also, okay? And remember, guys, we're also providing 10% discount on electrical system design course who are showing their masterclass certificate to our team members. Okay. And grab this opportunity. Thank you. All the
Yeah.
best.
Guys, one thing I can say from the team of HIW is that this is a summer time where you need to build your career. This May month, we are intensively starting the batches on electrical, VLSI, civil and mechanical, where you'll also be having the tech enrich batch for the second years and third years, and you'll also be having the EV internships. So whatever the course you want to join, just feel free to contact the team HIW. We are always open for you people, and we are always we are something that what I have said is that HIW is something where the talent always meets the opportunity. So this is the right opportunity for you people. You can grab the opportunity and you can use this session. Hello guys, if everything is clear, if everyone is satisfied with the sessions and all, thank you for your 5 days patience. Thank you so much for your valuable time. I hope you have learned many things in this 5 days session, and hope many more things will come and will connect very soon. And most of you people will turn out for this batches, so that you'll get immense of knowledge, you get immense of opportunities in the market. This is Manjunath signing off behalf of HIW. Thank you guys. Thank you so much. Have a nice day. Good night.
Thank you, Manjuna. Thank you. Thank you guys for your patience listening, and thank you for being with us for all the 5 days. We HIW team signing off. We all let's hope that we all meet in our HIW office. Thank you. Have a good day. Good year ahead. Thank you.